Types of electric motors. The following are the common types of electric motors. Number 1, DC motor. 2, shunt motor. 3, separately excited motor. 4, series motor. 5, compound motor. 6, PDMC motor. 7, AC motor. 8, induction motor. 9, one phase induction motor. 10, three phase induction motor. 11, synchronous motor. 12, stepper motor. 13, brushless motor. 14, universal motor. 15, high hysteresis motor. 16, reluctance M motor. 17, linear motor. AC motor. An alternating current AC motor is a type of electric motor that converts alternating current into mechanical power by the electromagnetic induction phenomena. It consists of two main parts: an exterior stator and generates a magnetic field using alternating current, and an terminal rotor that generates a second magnetic field using an output shaft. Permanent magnets, reluctance power, and AC or DC electric windings can all be used to create rotor magnetic fields. In industry, three-phase AC motors are commonly used for bulk power conversion from electrical energy to mechanical work. The motor requires less energy to start and is more durable and long-lasting. Induction motor. An electric current is necessary for this motor to produce torque, which so obtained through electromagnetic induction from the stator windings revolving magnetic field. As a result, an induction motor without an electrical connection to the rotor can be constructed. Induction motors are widely utilized in industrial, commercial, and household applications because they operate at a slower speed than synchronous motors. These motors are sometimes referred to as asynchronous motors. It has a simple, durable design that is most modest in cost and requires little care. Single phase induction motor. A single phase power supply is used to power a single phase AC motor, as the name implies. On the stator, single phase winding is used, while on the rotor case winding is used. A pulsed magnetic field is created when a single phase supply is applied to the stator winding. Due to inherent in the pulse field, the rotor does not revolve. Three-phase induction motor. Three-phase induction motor converts three-phase input electrical power into output mechanical power using electromechanical energy. These motors are utilized in a variety of industrial applications and are designed to run on three-phase AC power supplies. Crushers, plungers, pumps, cranes, elevators, compressors, and conveyors are just a few of the applications. Series motor. A series motor is a collection of individual motors in which the field is connected in series with the armature winding, allowing a large current to flow through it. A series motor performing the same function as other motors in that it converts electrical energy into mechanical energy. This sort of armature has a power supply terminal on one end and a field coil on the other. When the external magnetic field is almost formed, a current carrying conductor cooperates with it, and a rotational motion can be produced for constant and variable speed electric drives. These are suited for both high and low power drives. Compound motor. The armature winding of compound types of electric motors is coupled to both series and shunt field coils. It carries enough magnetic flux in the armature to provide enough torque to help spin at the desired speed. This motor was created to improve the qualities of both of these motors. A shunt motor has a very efficient speed regulation, whereas a series motor has a very high beginning torque. However, the starting torque is lower than that of a series motor, and the speed regulation is less effective than that of a shunt motor. PDMC motor. Permanent magnetic poles are used in these types of motor. As the name implies, the magnets are radially magnetized and placed on the inner walls of the cylindrical stator in this motor. Because there is no field coil in this motor, torque is generated by the interaction of armature flux and permanent flux. The armature core commutator and armature winding make up a PDMC motor. A PDMC motor's operating voltage is 6 volts, with 12 volts available if a 24-volt DC supply is supplied from voltage sources such as batteries or rectifiers. PMDC motors are commonly utilized in applications that demand tiny DC motors. Synchronous motor. It is defined as an AC motor in which the rotor rotation is synced with the supply frequency. In this case, the rotor's rotation are all equal to an integer multiple of the applied current's frequency. The induction current is not required for this motor to function. In contrast to in induction motors, this multi-phase AC motor features electromagnets on the stator that generate a spinning magnetic field. These motors are frequently employed in applications and that need precise and constant action. A stepper motor. It is a type of electric motor that separates a complete revolution into many equal steps. As long as the motor is suitable is called for the application. In terms of torque and speed, the position of the motor can be controlled by running and holding on to any of these stages without any position sensor for feedback. The motor and the stator are the two most important components. The rotor is the motor's revolving shaft, while the stator contains the motor's fixed parts, which are electromagnets. Without the need to activate the motor, these motors can give flexibility and consistent holding torque. They are utilized in 3D printers, textile machines, and printing presses, among other things. Brushless motor. It is a type of brushless DC electric motor that operates on a direct current DC electric power supply. The motor is equipped with an electronic controller that alerts DC currents in the motor windings, resulting in magnetic fields that revolve in space and follow the permanent magnet rotor. The controller also controls the motor's speed and torque by adjusting the phase and amplitude of DC current pulses. Electric motors of this sort are extremely efficient at providing huge quantities of torque across a wide speed range. Brushless motor are used in a variety of applications including hard drives, CD, DVD players, pumps, and so on. Universal motor. The universal motor is a type of electric motor that can run on either AC or DC power and creates its magnetic field as using an electromagnet as a starter. Variable speed, a strong transmission torque, and a high beginning torque are all attributes of this motor. Universal motors are widely found in vacuum cleaners, sewing machines, and other household appliances. A universal motor is built similarly to a DC series motor but with a few modifications to allow it to run on AC power. Electric motors of this sort are built to spin at high speeds of more than 3500 rpm running per meter because the field coil and armature will have reverse polarity with the current supply. This motor will run effectively on an AC supply. Hysteresis motor. It is a cylindrical rotor asynchronous motor that operates on induced hysteresis loss in a steel rotor with high retention. It can operate in one of three phases and is noiseless to the environment as well as maintaining a consistent pace. Reluctant M motor. On a ferromagnetic rotor with no winding, reluctance motors have no permanent magnetic poles. These types of motors give a lot of power for a responsible price, making them appealing in a variety of applications. Linear motor. Linear types of motors have a straight rotor and a starter, thus instead of producing torque through rotation, it produces a linear force along its length. These electric motors, on the other hand, are not always straight. DC motor. DC motors are rotational types of electric motors that transform electrical energy into mechanical energy. This indicates that the electrical energy input is direct current which is then transformed into mechanical rotation. The magnetic field produces forces that are used in the most common types of DC motors. Shunt motor. It's type of DC motor in which the field winding and the armature winding are connected in parallel. As a result, the motor's two windings are exposed to the same voltage source and it maintains an inductive speed under any load. Separately excited motor. The main supply is delivered independently to the armature and the field winding in these types of electric motors, as the name implies, because the field winding is energized by a separate DC source. The current from the armature does not travel through it.